NEC 230.28 addresses service masts used as supports for service drop conductors, stating they must have adequate strength or be supported by braces or guys to withstand the strain. Determining adequate strength isn't explicitly defined in the NEC 230.28 itself, but involves several factors. Firstly, the material of the mast plays a crucial role. Steel and aluminum, for example, possess different strength and durability characteristics. Secondly, the diameter of the mast is important. A larger diameter generally equates to greater strength compared to a smaller diameter. Thirdly, wall thickness matters, adding to a mast's rigidity and load-bearing capacity. Fourthly, the length of the mast affects its stability. Longer masts are more prone to bending and swaying, potentially needing additional support. Fifthly, load conditions, particularly expected wind and snow loads at the installation site, dictate the required strength of the mast. Regarding the 3-foot reference mentioned, the NEC doesn't contain a specific 3-foot rule for service mast supports. The inspector might be referencing a local code exceeding the NEC minimum standards. It's essential to verify this with your local building department to understand specific local requirements. To determine adequate strength, consulting with a qualified electrician or a structural engineer is highly recommended. They can evaluate the factors mentioned earlier, calculate necessary support based on load conditions, and ensure compliance with both the NEC and local codes. This may involve calculations to determine the bending moment and shear forces on the mast due to wind and ice loads. They might also consider the safety factor required by local regulations. For example, if the calculated bending moment in the mast is 1,000 foot-pounds and the safety factor is 2, the mast and its support system must be able to withstand a bending moment of 2,000 foot-pounds. The electrician or engineer will use appropriate engineering principles and formulas to determine the required size and strength of the mast and any necessary support structures. This could include using guy wires, braces, or a combination of both. The guy wires should be attached to the mast at a point that is high enough to provide adequate support, but not so high that it creates excessive stress on the mast. The braces should be securely attached to the mast and the building structure to prevent the mast from bending or swaying. In addition to the structural considerations, the electrician or engineer will also need to consider the electrical requirements of the installation. The mast must be properly grounded to protect against electrical shock. The conductors must be properly sized and insulated to prevent overheating and short circuits. The installation must comply with all applicable codes and regulations. To further elaborate on the material properties, steel offers high tensile strength, making it suitable for resisting significant pulling forces, and high yield strength, which indicates its resistance to permanent deformation under stress. Aluminum, while lighter, has lower strength compared to steel, but offers excellent corrosion resistance. The choice depends on the environment and load requirements. Regarding diameter, a larger diameter increases the cross-sectional area of the mast, which directly contributes to its resistance to bending. The relationship between diameter and strength is not linear. A small increase in diameter can result in a significant increase in strength. This is because the bending moment of inertia, which is a measure of the mast resistance to bending, is proportional to the fourth power of the diameter. In terms of wall thickness, the walls provide greater resistance to local buckling and crushing under compressive loads. This is particularly important for masts that are subjected to high wind or snow loads. The wall thickness must be sufficient to prevent the mast from collapsing under these loads. When considering the length of the mast, longer masts are more susceptible to wind-induced vibrations and oscillations, which can amplify the stresses on the mast and its supports. This is why longer masts often require additional support, such as guy wires or braces. The support should be designed to dampen these vibrations and prevent them from causing damage to the mast or the service drop conductors. Calculating wind and snow loads involves using local weather data and engineering formulas to determine the maximum forces that the mast will be subjected to. Wind loads are typically calculated based on the wind speed, the surface area of the mast, and the drag coefficient that depends on the shape of the mast. Snow loads are calculated based on the average snowfall, the slope of the roof, and a snow load factor that accounts for the accumulation of snow on the mast. Regarding local codes, it is essential to check with the local building department to determine if there are any specific requirements for service mast supports in your area. Some jurisdictions may have more stringent requirements than the NEC, while others may have specific requirements for certain types of installations. It is also important to be aware of any local amendments to the NEC that may affect the requirements for service mast supports. When consulting with a qualified electrician or structural engineer, be prepared to provide them with information about the location of the installation, the type of service drop conductors that will be supported by the mast, and any known wind or snow load conditions in the area. This information will help them to accurately assess the strength requirements for the mast and its supports. In addition to the factors mentioned above, the electrician or engineer will also need to consider the type of soil in the area. If the soil is soft or unstable, it may be necessary to provide additional support for the mast, such as a concrete foundation. The foundation should be designed to withstand the weight of the mast and the service drop conductors, as well as any wind or snow loads. It should also be deep enough to prevent the mast from tipping over in high winds. The type of connection between the mast and the building is also important. The connection should be strong enough to withstand the forces that will be applied to it by the mast. It should also be designed to prevent water from entering the building. The connection may be made using bolts, screws, or welds. The type of connection will depend on the type of building and the type of mast. The type of service drop conductors that will be supported by the mast is also a factor. The conductors should be properly sized and insulated to prevent overheating and short circuits. They should also be supported by the mast in a way that prevents them from sagging or touching the ground. The conductors may be supported by insulators, clamps, or other hardware. The choice of hardware will depend on the type of conductors and the type of mast. The National Electrical Safety Code, or NESC, provides additional guidance on the design and installation of service masts. The NESC covers topics such as the clearance between the service drop conductors and the ground, the strength of the mast, and the grounding of the mast. The NESC is not a mandatory code, but it is widely used by utilities and other organizations that are responsible for the design and installation of electrical systems. It is also important to consider the aesthetics of the installation. The mast should be installed in a way that is visually appealing and does not detract from the appearance of the building. The mast may be painted or otherwise finished to match the color of the building. The conductors should be neatly arranged and supported by the mast. The installation should be done in a way that is professional and workmanlike. Proper maintenance is also important. The mast should be inspected regularly for signs of damage or deterioration. Any damage should be repaired promptly to prevent further damage or failure. The mast should also be kept free of debris, such as leaves and branches. The debris can accumulate in the mast and add to the wind load. In summary, determining the adequate strength of a service mast involves considering material, diameter, wall thickness, length, load conditions, and local codes. Consulting with professionals ensures accurate assessment and code compliance. Ensure the installation is done safely and professionally.